Hello and welcome to today's video for section 6.5 for fossil fuels. Since I am not in school today, and I mean, uh, I want you to use this as some, potential talking points for tomorrow when the each of you and your energy resources you're going against me as fossil fuels. So let's get right into it. Fossil fuels, there are really three main categories: coal, natural gas, and oil. And the way that we get the energy from these fuels is by burning them. All right, so the burning is called combustion. The energy is not necessarily being generated, right? It's stored in the chemical bonds of these fuels. However, it's going to get released upon combustion. So the process of combustion, I want you to think about that. Hopefully you already know what that means, but anytime that we burn something or combust something, we're basically combining it rapidly with oxygen, and doing so is going to release lots of heat. All right, so for fossil fuels, as well as for every other energy resource that we're going to be talking about in this unit, you need to understand that there's a whole lot more that goes into each of these energy resources than just what you see, right? When you see a windmill, when you see a dam, when you see a coal burning power plant, when you see a nuclear reactor, there's a lot more that goes into that energy resource than just what you see where we're getting it, right? Where the windmill is turning, or the dam is letting water through it, where the solar panels are just there, where coal is being burned, right? There's a lot more that goes into it. So for fossil fuels especially, and then also pretty much for nuclear and geothermal and a few others, exploration is going to be important because that helps us to find fuel deposits or places that are viable. Then comes excavation. So excavating coal, oil, natural gas. Okay, that's all the case for all these fossil fuels. Don't forget that, I mean, if we're trying to find uranium, we're going to have to drill for that too. I'm sorry, not drill, mine. Okay, processing it. What we get out of the earth is usually not going to be perfect right from the get-go. So we got to process it, take out some of the impurities, make it good. Transportation. So once it is ready and processed, get it to the consumer. And that might involve more than, it might involve electricity generation too. And then of course, then using the fuel, well, we have to consider that in this case for burning fossil fuels, that there are going to be some implications there too. All right, so first things first, exploration. So exploration is just our setting out, trying to find things like fossil fuels. Doing so, that's going to disturb ecosystems. It can cause habitat fragmentation. We might have to remove habitat if we're making space for the exploratory well, okay, or drill. So roads need to be built, and then vehicles and machinery need to be brought in, so that can fragment habitat. All right, so now specifically for oil and gas exploration, these are going to be fairly similar. So the landscapes need to be surveyed. Oil and gas are going to be found underground. Okay. So scientists are going to want to look for good, promising rock formations, for example, like the Marcellus Shale right below us. And then from there, they're going to need to do some surveys that involve seismic waves, shock waves. So using explosives or using, really powerful machinery to kind of send a little shock wave, not really little, but shock waves through the ground. And it's going to go through the ground, and it's going to eventually bounce off of certain rock formations, and we're trying to figure out if those rock formations have coal or oil or gas. Okay, so this is kind of what it looks like. So there are going to be sensors around here, but our machine here is going to cause a little shock wave here, and it's going to go out at certain angles. And then based off of whatever angle it's being sent out, and then where it hits, it's going to come back up to the surface. And the sensors up here are going to be able to kind of track that, and you know, the amount of time that it takes to get all the way back up is going to give us an idea of how deep it is. Okay, so this is kind of what an exploratory well for natural gas is going to look like here. All right, so now once a potential site has been identified, then an exploratory well is going to get drilled. So again, we're still kind of exploring, trying to figure out if it's going to be good enough. So at this point, we've established that there is something. So then an exploratory well needs to be drilled in order to get an idea of, you know, the type of stuff that we got down there and how much of it we've got down there. So if it is deemed to be profitable, okay, easy enough to get a lot, then a well is going to get built in order to extract the oil. Same thing with coal exploration. Scientists can drill out a sample within the core where the coal is through that seam, and be able to analyze the type of coal, right? Do we have bituminous? Can we strike gold and get anthracite, and so on, right? And also the size of that seam, how far down it is, where it is, how big it is, and so on. All right, so the excavation now, remember for coal, we've got surface mining, things like strip mining. We've got subsurface mining, so that's going to involve building a shaft, going deep into the earth. So how exactly do these work? Think back to when we talked about mining in our previous unit. Okay, so what are some of the differences between surface and subsurface mining? What are some benefits of each? Why don't you go ahead and think about that? You know, maybe pause the video, write a few things out, and then I will move on. All right, so here we have a few different wells here. So for the excavation here, we've got a deep water oil rig. So this is very similar to like Deepwater Horizon. Now, Deepwater Horizon was just an exploratory well, but if things would have gone well, then there would have been a full-scale oil rig built there. Okay, this is an on-land oil drilling rig. And then this is something that you've probably seen before. This is an oil pump jack. So once the well has been built and the oil is able to get extracted, then this is going to help to draw it towards the surface. Okay, technical stuff. If you want to get into the technical stuff, I'm not going to get into it too crazy. But a few things to get out of this is that the well, right, is going to go deep, and there is a lot that goes into the well. It's rather thick for where the oil is going to be coming out through the middle. Okay, so it's fairly well protected to avoid the oil and other stuff to leak out. Okay, now natural gas. Well, remember, we got the fracking. So that's really what is mainly used for natural gas. So drilling a well down and then actually turning the well. So exploring all the way down, getting into the seam, and then making it go horizontally. And then sending down a bunch of water and sand, other chemicals to then just kind of cause an explosion to break up the shale, to let the natural gas kind of leak out, and then it can be drawn up through the well like a straw. Okay, now what about processing? right, so we have explored, we've excavated, now we kind of need to process it, right? Because we've got coal, we've got oil, even natural gas is not going to be perfect when we get it right out of the ground. Okay, so there's some processing that is involved. That itself is going to require energy. That is also going to cause, some pollution. Right? Anytime anything gets processed, even the fossil fuels themselves, well, that's going to require an input of energy. Okay, so for example, coal is going to have other rock, ash, and sulfur in it. That stuff needs to get removed, right? Because we don't want to be releasing too much sulfur when we burn the coal, because that's going to release sulfur dioxide and lead to acid rain. Okay, the rock and clay. Remember, that's a component of small pieces of rock, very small pieces of rock. But these things are going to reduce the quality of our coal and the amount of heat that we're going to get from the coal as well. Okay, so we're looking to remove the impurities, not only to increase the heating value, but also to reduce the amount of emissions that we will get from that coal. Okay, natural gas is considered wet when it's extracted because there's water and going to be other hydrocarbons in the natural gas. A lot of those things are going to get removed so that we have as much methane as possible in the natural gas. So things like sulfur, hydrogen, sulfide, carbon dioxide, and nitrogen, and even helium, those things have to be removed. Petroleum. So for these other things, they have their own type of processing for petroleum. We're basically going to heat it up. We're not going to burn it, but we're going to heat it up and do what is called distillation. So this is bringing things from the liquid state into the gas state. So the most volatile things are going to reach the gas state first. So over time, as we heat up the petroleum more and more, right, we're going to get the things that have the most volatility, as we would say in chemistry, meaning that it will essentially boil off first or vaporize first. And then as we add more heat, the things that are less volatile will also vaporize. But since only, depending on their boiling points, each of these different components are going to boil at different times. As we add heat to the petroleum, we're able to separate each of the components through distillation. Okay, now transportation of fossil fuels. Well, transporting these things to the consumer, right? If they're drilling for oil up in Alaska and Canada, well, we got to get that to the consumer down here in Pittsburgh, Pennsylvania. Maybe we're even buying it from other countries too. So the gas and oil have to be transported in certain ways. Right? So if it's over land, well, we can build a pipeline. Okay, so you can see here we got a few pipelines. So the gas can get transported through here, the oil can get transported through here. Coal, not so much, right? Gases and liquids can go through here, but solids not going to be able to work through that. So there are things that we can do. Right? Oil can get transported by tankers. So there are these are really large ships essentially that have a large capacity for oil. So the Exxon Valdez was a really bad example of an oil spill where essentially it kind of ran aground near the coast of Alaska, and a ton of oil was spilled. I don't have the specific number on me, but a ridiculous amount, and that really harmed the ocean ecosystem there because animals like mammals that have fur, the oil gets trapped in their fur, and that has a major detrimental effect on them. Okay, coal can get transported like by barges or train. It can actually also get crushed down, and it doesn't dissolve in water, but you can mix it with water to form what is called a slurry. So it's just solid stuff suspended in water. So that slurry can then get transported by pipeline. So coal is manageable through here, just a little bit goes into crushing it. So again, energy is going to be required there. And then mixed with water, which is also going to cause a strain on water resources as well. Right, and now finally, how about the usage? So coal, natural gas, and gasoline all have pretty good net energy. So coal has very high net energy for the generation of electricity, meaning that it burns nice and hot. It's going to be able to give us lots of energy. And high net energy, meaning that all of the energy that goes into getting it, extracting it, processing it, etc., is going to be offset very well by the amount of energy that we get from coal in order to generate electricity. Natural gas also is pretty decent, medium net energy for the generation of electricity. Gasoline, it's not really going to be used for generating electricity. However, it is great for using it as a fuel for transportation. So diesel, the gasoline itself from oil, they're going to have medium to high net energy for transportation. And natural gas can actually be used as a fairly decent transportation fuel as well. Natural gas is used very commonly for space heating. So your homes are probably heated by natural gas. Some of yours might be heated through electricity. That's possible too. But very commonly, natural gas is really the source of heating for homes. All of them can be used for industrial heating processes. So if we need to heat something up in industrial, we mean very, very hot. Well, each of these can be used. Oils actually has a really high net energy, whereas the other ones are about medium net energy. Okay, so we have reached the end. So why don't you take a few minutes to consider some answers to these questions. So what are some of the consequences of fossil fuel usage and combustion? And which of the fossil fuels burns the cleanest? So I want you to answer this question on your own. What are some of the consequences of fossil fuel usage and combustion? All right, number one, I want you to consider these because you're going to need that for tomorrow. And number two, just as a way of wrapping up this section. Okay, now the answer for which of the fossil fuels burns the cleanest, which is going to be very relevant for you, so make sure that you write this down somewhere. It's going to be natural gas. Natural gas is the fossil fuel that burns the cleanest. You will probably get asked that, so make sure that you know that. All right, well, that's it for this video. Hopefully you found this helpful. Be ready to bash on some fossil fuels tomorrow. I will bring my A game, so I expect all of you to bring your A game too. All right, have a good day.